I do just a quick talk about how IBM has been taking all of the technologies that you've been hearing about over the last hour or two and making it accessible and usable by developers worldwide. We kicked off an initiative earlier this year called Call for Code, and the idea was to go to anybody who wanted to be a developer to take action to help alleviate initially natural disasters, so prepare for them or to recover from them, but using technology. So the people that weren't in a position to go and offer their physical help, how could they help by using some of their skills or their interests? We launched a program worldwide, Call for Code. It was done with the David Clark cause organization, which did a lot of the branding and marketing for it. We provided technology, the Linux Foundation provided technology, and we've been given access to our platforms. It was done as a competition to give people a bit of an incentive to do things, but the idea was to get AI and apply it to solving these kinds of humanitarian problems. The big challenge that we don't control would be natural disasters, but hopefully, as we've learned over the last 6 months or so, we'll be able to apply some of the technologies, the learnings that we've picked up on using them to avert or recover from man-made disasters as well. So, a little bit of background. I'm not going to dwell too much on these, but the idea is, last 20, 30 years, we've seen huge impact from natural disasters. Floods, fires, I mean, very topical this week about the fires that are raging across Western California. Not being able to predict it properly or to recover or to place equipment in the right way at the right time to alleviate those, and then to prepare for what happens afterwards. There are thousands of displaced people, homes, animals. How will we get the right equipment, the right people in the right places to do it? So using AI algorithms to predict those things, using vision to do kind of in-theater inspections and do periodic surveys so we can see what things look like now as opposed to what we thought it should be like, and see how that's going to affect what we do for moving equipment around, moving people, relief, food, and so on. Right. The idea being, if we know what things can be done and we can work out some kind of economic model that can work out what's our opportunity cost here. Is it better for us to pre-place things at a cost, knowing that we're avoiding some uncontained cost if we allow things to happen? Last 20 years, 2.5 billion people have been affected in some way by natural disasters. Usually it's going to be floods, they're the most significant ones. Hurricanes tend to be reasonably localized, but the risk profiles of those are going up now, so that you end up with consequential impacts with fire, floods, power lines outages, food disruption, and so on. 20 years, that's where we've been so far. In the last 10 to 15 years, we're seeing enormous growth in the impact of flood, particularly. So a lot of the people that were responding to our call were trying to address was predicting floods, predicting what to do about floods, where to put equipment, how to move people around, and being able to recognize what kind of flooding was going on and where you might get it. The whole idea here is mitigation, either before or afterwards. Right? We reckon that there was about 22 million developers all over the world. Some of them are professional developers, some of them would be what we would call citizen developers. Some of them maybe didn't even know they were developers. They were thinking about doing something, being part of a team. And the idea for our kind of personal self-interest, if you like, from IBM's perspective, is the more people that are doing these kind of things, the more people are thinking algorithmically about solving problems, the more chances they're going to try and use software to do that. They'll use systems to make it repeatable and so on, right? So lots more people get enabled with the idea that you can use these services quickly without necessarily understanding how things are working underneath. If they're applicable and they can be embodied quickly into applications, that means you can help solve this year's version of a problem and not worry about solving it for all time. You work on it, work on it for next year. The model changes, a different geography, you pick up more information, you want to be able to apply that quickly without necessarily being involved in the underlying technology so much. So of those 22 million people, we were trying to get them interested in 6 challenges. You can't read those really, but there were 3 areas we were trying to work on. One was to improve logistics by knowing what weather was like, being able to look at topology and planning for disruption. The other one was around using AI to help with language, real-time communications, setting up chatbots that were being fed with real-time information, and using some kind of almanac to help predict what things might be of interest to people, doing translation into different languages, coming up with the right terminology for the users to make it applicable to them at their time, right? And then finally, on this particular one, look at using deep learning for doing vision. So lots of applications kind of emerged where people wanted to take pictures of things, have historical views of things, and classify them really quickly. Not into great big details about the famous pictures of, is it a giraffe looking over somebody's shoulder while they're sitting at a table with a parrot? They wanted to know, is the house still there, or has it been burned down, or potentially has it been subjected to arson? So there's another aspect to these things where you get a disaster, is the human side of it, where people try and manipulate the situation as well. So insurers are really interested in what can we do to make that information useful to help people who are really in need quickly, but also to help us detect where there might be something that's not quite right. Someone's trying to exploit a situation for their own unjustified benefit. So we ended up with a number of kind of submissions that all had a common theme to them, using vision, using small scale classification, so multivariate classification, but really only looking for 3 or 4 values. Is it there? Is it not there? Is it flooding? Is it not? Has it been on fire? Is there a diesel tanker in the right position? Those kinds of bits of information. So we set the call out. The competition was time. Is that me? Oh, is that the foghorn? Somebody did mention there was a foghorn. So it's the timer. Thank you, Ashley. That's the new way of saying speed up. The competition finished at the end of last month. We had a load of submissions. Give you some numbers. Of the 22 million potential people, we had well over 100,000 developers submit. 2.5 billion people have been exposed to the story and understand what's been going on with all the partners to bring this thing about. The idea is that this is now established and we'll do them again next year. So developers all over the world can join in, participate, and bring about change either locally or anywhere else in the world they have an interest. We did it with a cash prize. We actually introduced more cash prizes as the pool got bigger and bigger. And the idea is that the winning teams are then fostered over the next couple of years to deliver a product, but it's an open source product, so anybody else can take it and build on it. We had lots of celebrities who were doing their things, but they were out basically doing the social amplification to tell people about the project. The details here, you're not going to be able to read, but the winning team, called Project OWL, were a diverse group of people. What they did was look at flood and the communications that get disrupted by flood. We were offering a software platform. They chose to do it in 2 ways. They did a hardware solution, physical technology, as well as software to do predictions. So they came up with a LoRaWAN-based system called the cluster duck, which allows them to basically scatter buoyant sensing devices which do self-meshing, build a dynamic mesh, and then have a whole load of sensing information that they can relay back. So that is that's an open source technology which they'll be able to offer to anybody who wants to do this kind of flood-based mesh discovery. Right. IBM also ran it internally because all the rest of us were excluded from the program. We couldn't win any of the prizes, but we had 300,000 to 400,000 people who might have been interested in doing it. So we ran the competition internally as well. And there was a group that did something that based around predicting the impact of earthquakes in schools, in areas where there were likely to be building damage for relatively high quakes, and also some minor quakes could cause minor damage. So what they wanted to do was predict, is it worth moving the kids out of the school or leaving them in the school? So they built a communication system around that. They put in a little bit of sensing as well to do tremor sensing. The vision stuff led us to say, well, let's start off another competition, which we're piloting in the US over the next 2 or 3 months, which is we'll give away drones and then let people try doing stuff with drones using the vision technology that we offer through our Watson platform to do that kind of really fast, small numbers of images, relatively small numbers of images to help you do classification, and then seeing what we get out of it. We offer platforms to do it, so you've got nice simple patterns that you can use, and then you choose which kind of images you want to do. So really repeatable. You can use the AI technology without having to think about what kind of network's in there, how deep is the deep learning system that's under there, how many thousands of images have had to go through this training engine. We've built and trained the image classifier so that you can just add 200 to 300 images per class. That gives you stuff, and as you get going with it, you can then do kind of cognitive training on it. And then you'll see lots of these things, because I'm a huge fan of it, is Node-RED appears in here again. Even the people that are wanting to do this, these applications don't need to be coders. They just need to be able to think logically, define a flow, and build it in with and prototype it. Because the idea is 6 months' time, you might want to change it quickly. Somebody else might want to take it and build something new with it. Mark's talk about using Node-RED, well, mentioning Node-RED, I don't know if it was in a lot of detail on it. But you can use it for industrial systems, you can use it for commercial systems, and of course you can use it for humanitarian relief as well. So I'm keeping it short, because I'm also hungry. The idea is we run this program for 6 months to say, let's get it going, we'll get it off the ground. It's not a one-off thing. Everything that's done will be published out as open source technology, so people can reuse that. And now we're looking at, well, what other things could we address? Is it just flood? Is it earthquake? Is it hurricane? Or is it things like pre or post-war? What do we need to know about what population movements are going to be like in the event of a war? What can we do to alleviate that, mitigate pre and post-event, or during the events? So there'll be a man-made aspects to it as well, man-made disasters. So that's going to carry on now into next year. We'll do another round, and then we'll build on those and carry on all the next year. So the partner network that's contributing to this is growing all the time. So I hope that any communities, particularly communities where you've got a lot of local contact. So island communities are great at doing these things together, because you've got a council, you've got the innovation groups, the startups, and the thinkers all actually know each other. So being able to get together and come up with quick decisions about what you might be able to do is exactly the kind of thing that goes into this thing. So being able to commit into that is great potential for localized communities. I'm going to be here with Alex Keeble and the AI Frenzy area. So we've been doing these kind of tours and talks over the last 3 or 4 months. If you want to come and talk to us a bit more about stuff, then I'll be there. And now it's lunchtime.